Hello, we're going to start talking about enumeration types today. Until now, we've used built-in C++ data types, int, float, double, char. Well, now we're going to look at what an enumeration type is. And a traditional enumeration type is just a type whose values are defined by a list of constants of type int. Right? And when we define an enumeration type, we can actually use any int values, assign that to our constants, or we can use what's defined by default. So what I've done is I've got a list here of directions. And when we create an enumeration type, we use the keyword enum, E-N-U-M, right, for enumeration. And then we give a name to our type. Right, in this case, we're working with directions, so I call it direction. The textbook we're working from shows that the convention is to start the name of the type with a capital letter, but notice the entire word is not capitalized. It just starts with the name of a capital letter. Inside, then, this list of curly brackets, so we obviously use curly brackets here in our list. We put a list of names for our constants. Now, constants by good programming form are written in all caps. That's why these are written in all caps here. So I've written north, south, east, and west. And when we don't assign an integer value to this value, then C++ just starts with the first one on the list and assigns an integer value of 0. The next one is 1. 2, 3, and so on, depending on how many you have in your list. So what this example is doing, right, is I've created this enumeration called direction. Notice at the end of the list, after curly brackets, there is a semicolon. Right, so here in main, all I'm going to do is I'm going to print out the integer values that are stored in here. So I've got the cout, right, we're going to print out this string indicating which one we're printing, north, south, east, or west. Then we'll actually use the name constant north, print that out so you can see what the integer values are. So let's just run that. And we're going to see 1 per line when this comes up. And so now we can see north equates to 0, south equates to 1, east to 2, west to 3. All right. And if you wanted to change that for some reason, right, if you wanted north to be 7, south to be 4, I'm just arbitrarily creating values, east to be 3, negative number, remember ints can be negative, or for some reason you wanted that to be -1. Let's just go ahead and run this and see that we have these values now. All right, so now that we've assigned values in the list, north is 7, south is 4, east is 3, west is -1. So positive and negative numbers can be assigned to these. Let's take a look at what happens if I just assign a number to the first one. So if north gets assigned 7 and the rest don't get assigned values, the compiler is going to like that. The compiler is fine with it. What you see, what happens is when you assign the first one a number, north got 7, everything after that, if there's no specific assigned number, it's just incrementing that by 1. So 7, 8, 9, and 10. Now, I don't know that I necessarily recommend that method because it's not as easy for us to read that and remember what values these should be, but just to give you an idea of how this works. These come in handy. You can use them. I often use them in state machines, right? If I'm working with hardware and I need to label the state of things, so I use them for status messages, right, which is a state. Right, I can use them for particular error messages to indicate what error state, if any, I'm in. So I find they come in very handy in certain situations. We can use them in if statements. So what we could do is we could create a variable of type enum. I'm sorry, of type direction. So our type that we made is called direction. And I'm just going to call this which way. Right? And I could assign something to that, north. And let's just print out which way. print out what's stored in a variable. I'm going to go back to this being 0, 1, 2, and 3. And maybe I'll comment this out below so this doesn't print out. Let's run this. All right. And you can see now we've got which way printing out 0 for north. All right. This can come in handy too if we're generating random values. So let's go ahead and say which way is equal to rand mod, remember our formula high minus low? Well, high in this case is west, minus low is north. I add 1 to it, and we add back on the low value north, which is 0. Seems a bit crazy here. All right. And instead of assigning north to this, I say it seems a bit crazy because adding on 0 really has no effect. But let's now print out which way below this. And all right, I got a build error. A value of type int cannot be assigned to an entity of type direction. So remember, rand function returns an int, and actually using rand, I should have included the C standard library. So if I want to turn this into a direction, right, this is returning an integer, but this thinks it's type direction, not type int, even though it's using integer constants for this. So in that case, I believe I could statically cast this to an int, sorry, not to an int, to a direction. Put that in parentheses for the static cast. And now let's try this. All right. So now we didn't get any compiler errors. In this case, it just assigned a value of 1 here. Right. And if I wanted to run this, so let's see the random number generator. Actually, let's for right now use the same string of random numbers. So I'm going to say for int I equals 0, I less than 10, plus I. All I want to do is I'm going to run this multiple times. So we can hopefully see this getting different directions. Right. So now if we run this, right, we had 10 different, we ran through the loop 10 different times. We simply called rand to give us a random direction, and you can see we got 1, 3, 2, 0, and so on. Right. That can be handy if you're working on a game, some sort of simulation, right, that you can generate these numbers. Now we could generate number, actually all we did was generate ints. We still didn't really necessarily use north, east, west, or south. So we could do something as like this. We could generate this, and then we could use something, we could use an if statement, or I'm going to use the switch case structure that I prefer using a lot of times with this. So I want to switch on which way. All right, switch case structure, switch on which way. So it's like I'm saying if which way equals so on and so forth. So I can say case north. And I'm going to move this here. Actually, let's print out which way. And now let's just say go north. All right. So I'm saying if which way equals north, we're going to print out the message go north. We're going to break here. If which way equals south, we'll just print out go south. East. I'm going to say go east. All right, hopefully you're getting the idea now. Case west. Go west. Break. We shouldn't really need the default case. We kind of carefully controlled our output. If I put a default case here, I might say something like see out, error, direction unknown. And that's the end of my switch case structure. All right. So let's try running this now, right? So this comes in, like I said, this could come in handy. We're just printing out messages, but we might be calling functions. This would come in handy if we need to call some sort of function. Like if it's a game and our character should go north, well, we might want to call some sort of functionality that changes the direction, makes a move in that direction, right? And these labels just happen to make your code easier to read. Because if instead of north, south, east, and west, if you just had case 0, case 1, case 2, case 3, that's not as intuitive to read as these particular directions are, right? So we use it to make it more human readable, right? Doesn't make it easier for the computer to understand because remember these are using the integer constant. So in this case, right, random number generated, first one is 1, we get go south. And we could do something like we could put this in its own function. And I'm going to call this handle direction. It's not really going to do much of anything. I'm going to send it in direction type. Again, I'll probably just call this, maybe I'll call it dir for direction. What I'm going to do is I'm going to put this code in here. And instead of switching on which way, my parameter, his name is dir. All right. Here, I'm just, once again, let's create int I equals 0, while I is less than 10, right? Similar to our for loop before. We're going to generate the random number. We're going to print out what the random number is. And then we're going to call our function, all right, handle direction. Now this function takes one parameter, right, of type direction. Well, we have a variable here, type direction, named which way here in main. So if we pass this which way, and maybe instead of having the end out here, just print out which way, the integer. Is which way? Let's print this out and see what this looks like. So the idea is we're going to generate a random direction. I'm just going to print out the integer value so you can see that. We're going to call the function handle direction, which is just going to run the switch case structure that we had earlier, but we put it in its own function. This should run, well, 10 times as long as I remember to increment I equals I plus 1, or plus plus I, or I plus plus, lots of different ways we can increment 1. All right. And so now you can see, right, we ran through. We got our 10 different random numbers as this loop through, but the first one was 1. We called this function. We passed this value of 1 to it, or this direction to it. Based on that parameter value, then it executed, well, 1 we know is south from our list. 3 is west. There's case west. Right. 2 is case east. When we get a 0, it's north. We see go north. Right. So there's just a way that you can use enums in your code to control actions. All right, and those are traditional enumerations. C++, the 2011 standard, introduced new versions of enumerations that you could write classes or strongly type, so it would check the data type. It also allows you to create types, non-integer type enumerations, I should say different size integer type enumerations. We have not started writing classes yet, but in this case, we can see that enums, well, they do come in handy. I was going to say, in this case, you can see they come in handy, but we've not really fully worked through an example where we said, oh, they come in really handy. All right, so here's just the basic. That's the end of this tutorial on basic enums. I'm sure we'll have an assignment very soon where we will start using them.